Hey there, all you cool cats and kittens. This is Creating Electronic Music with ChucK. In our last tutorial, I described how ChucK lets you use loops to execute the same lines of code multiple times. In this tutorial, I'm going to talk about arrays. Back in lesson 2, I described a variable as a position in memory that you give a name so that you can refer back to it again and again. We also discussed how variables have what we call types so that ChucK can expect your variables to behave certain predictable ways. An array is what's called a collection of variables. When you tell a programming language you want an array of variables, you're saying you want a bunch of those variables back to back and you only want to name them once. If you think of a variable as a position in your system's memory, then an array is a group of those positions set back to back so that it's super easy for your program to jump back and forth between them. This is very useful when you have sets of data containing multiple things that you want to treat the same way. Let's see how it works. To declare an array, you start by stating the type of variables that will be in it, followed by the name, followed in brackets by the number of those variables you will be using. Because you're telling ChucK where in memory these variables will be sitting, it's important to know that number up front. Let's start simple by declaring an array of strings. I'm going to call it words, and in square brackets I'm going to tell ChucK that the words array will contain 2 strings. Now, the way you talk about the variables within an array is using what's called the array index. When you use an array name, you follow it, once again in square brackets, with a number. The number designates which of the array's multiple variables you want to access. Now here's a tricky thing that is easy to forget and mess up. The first number in the array is always 0. In an array with a size of 2, the 2 variables are accessed by talking to indices numbered 0 and 1. This can be counterintuitive, and you will almost definitely forget and cause your program to blow up someday by trying to use the array index that has the same ID as the length of the array, which is actually outside the array. Here's what it looks like when that happens in ChucK. So don't feel bad when that happens because it happens to the best of us. Just try to remember that the largest index in an array is always 1 less than its size. So as we saw here, we could access the string we put into the array I called words by using those indices. Now let's move into a more musical domain. I'll make another array called frequencies, and let's give it a type of int and an array size of 4. Now I'm going to assign 4 different numbers to it. The way we did this before was we built the array and then we assigned the numbers to each array position. As you can see, as the number of array positions goes up, this starts to look like a pain. There's a better way. I can start by writing inside a set of square brackets the values I actually want in the positions in the array. The values need to be separated by commas. After writing these, I use a special ChucK operator called the @ChucK operator, followed by the type, the array name, and a set of square brackets followed by a semicolon. You do not need to say how big your array is in this case. ChucK is smart enough to infer the number from your list. Remember when we said that an array is a bunch of variables laid back to back? The @ChucK operator is a special way to tell ChucK that, hey, there are a bunch of values I want you to put into memory at the address of this new array, and it lets you skip assigning the array members one by one by their indices. So, now we have an array of frequencies. Let's use what we learned last time about loops to make a for loop that iterates across all of those frequencies. Now, I manually put in my for loop that I wanted the loop to continue as long as I is less than 4. We can make this a little easier on ourselves by replacing that hard-coded number with the name of the array .cap parentheses. This will get the capacity of the array. When we do this, we can just change the length of the array by adding more stuff in those brackets, and we don't have to worry about updating it anywhere else. So, now we can play once through this array, and it will play all these frequencies exactly once. We can wrap our for loop in a while loop, and now it can play until we tell it to stop. Okay, so now we're really close to being able to tell ChucK to play some music. However, I don't know about you, but I personally don't know what frequencies correspond to actual musical notes. Luckily, we don't need to. ChucK has a built-in utility to convert MIDI note numbers into audio frequencies. Let's see how that works. Let's make a new array and call it pitches. Load it up with the values 60, 62, 64, 65, 67, 69, 71, and 72. Don't worry about why we're using these particular numbers for right now. I'll explain that in a separate lesson. Now we'll replace the for loop that used frequencies with this loop that uses pitches. And anytime we are pulling a value that is a pitch rather than a frequency, we're going to wrap it with std.mtof. Now let's play it back. So, what happened there? STD is short for the ChucK Standard Library, which is a set of convenience methods for common things that you'll want to do. We'll see more things that the ChucK Standard Library provides in future lessons. For now, we'll just look at the MTOF method, which stands for MIDI to frequency. It takes a MIDI note number and returns the frequency represented by that note number. That helps us out because things like oscillators ask us for specific frequencies, which we probably don't know off the top of our heads. So at this point, if you know about MIDI note numbers, you have enough information to make a basic repeating melody. There's a lot more to cover, but using what we've learned so far, you can do things like make a quick ringtone or an alert sound. In this lesson, we discussed arrays and how they work, as well as how to convert MIDI note numbers to audio frequencies. In our next lesson, we'll cover some very basic music theory to help you choose MIDI note numbers if you don't have any idea of what those numbers represent.